Friends, we have already done some theory about permutations and some problems on permutation. So now let us go to the next part of this lecture. This topic is called combination. Combination. So what is the meaning of combination? Combination means selection. So combination means selection. Combination means selection. What is the difference between permutation and selection? Selection is what? Suppose I have got 4 candidates coming for an interview, A, B, C and D. And I want to select only 2 of them. Select I would only 2 of them. So suppose I have selected AB. A and B I have selected. Somebody says, no, I have selected B and A. That's nonsense because it's the same selection, right? So AB and BA are same selection. That means the order here is not important, right? Only which objects you select, that is important. So this is called selection. But in permutation, AB is not the same thing as BA. It is a different arrangement. So here the arrangement or the order of the objects which you are selecting is not important. So selection means what? Order is unimportant. Now, where the permutation and combination come together. Suppose you have got a job interview and there are 4 candidates appearing for the interview. You are going to select only 2. Okay. So suppose I have selected candidate A, candidate B. Now, there are 4 chairs in your office, right? And out of those 4 chairs, you are going to allot those chairs to these 2 guys. So first chair, and the chairs are numbered. First chair, second chair, third chair and fourth chair. Now there is an arrangement. So if A goes to the first place and B goes to the second place, it's a different arrangement. And B comes to the first place and A goes to the second place, it's a different arrangement. So selection is same. You have selected only 2 people, same 2 people, but one selection gives you 2 arrangements. Okay. So in other words, if I want to select 2 objects out of 4 objects, there are only these many selections. Let us see. How many selections are there? Let us see all the selections. Okay. So first of all, I'll take A, then I'll B, then A and C, then A and D. So with A, I've got 3 selections. Then with B, I will take C. Then with B, I'll take D. And lastly, I'll take CD. That means 1, 2, 3, 4, 5, 6. So there are 6 selections. So out of 4, I have to select how many? Only 2. And that letter is called 4C2. 4C2 means out of 4 objects, I'm selecting 2 objects at a time, right? And that is equal to how much? That is equal to, as we have counted here, 1, 2, 3, 4, 5 and 6. The answer is 6 here. So that is called 4C2. Okay. Now, suppose I want to find out 4C3. 4C3. What does that mean? When I select 3 objects out of this, I am automatically rejecting 1. So if there are 4 candidates and I have select 3, means I am selecting 1 for rejection, right? So I am rejecting. How many ways I can reject? I have to reject only 1 person. How many people I can reject? Only 1, right? So there are 4 objects available. So there are 4 rejections available, right? So that means 4C3 has to be equal to what? 4. Correct? Because selecting 3 people is same as rejecting 1 person here in this case. Okay. So therefore, the total number of selections are 4C3 and that is equal to 4. Now, if you have got 4 candidates and all 4 are required, you have no choice. You have to select all of them. So that can be done in only one way, right? So 4C4 is nothing but only 1, right? Only one way you can do it. Okay. So this is how the selections are there. Remember again and again that if there are n objects and I want to select r objects, then when I select r objects, their order is not important. I can arrange them in any possible ways, right? So, and that notation for that is n, c, r. That means there are n objects available, out of which I am selecting r at a time. Okay. So total number of such selections is given by NCR, right? So I want to find out what is the formula for NCR. Okay, let us see. So let us say there are n objects. So n objects, I'll denote them like this: A1, A2, A3. This goes on like that. And there are n objects like that. So there are n objects. Now how many I have to select? I have to select only R. Okay. So I'm going to select only R objects out of n. Okay. So how many? So R objects are to be chosen out of n. So that is nothing but NCR. Correct? NCR. So if I want to select R objects out of n, then what will happen is those R objects that I am selecting, their order is not important. That means all those R objects will act like only one object. Okay. So that R objects can, so that means how many objects are left there? N minus R, right? So N minus R. So for me, NCR is always equal to N P R divided by R factorial. Why is it so? Because suppose you take n objects and you arrange them, you arrange R objects. So there are n objects available, but you are arranging how many? Only R objects you are taking and arranging them. Now these R objects, so how many ways R objects can be arranged? You know, how many R objects can be arranged out of n? That can be done in how many ways? NP R ways, right? So NP R ways. But these R objects are actually only one object, correct? So that means these R objects will give me only one combination. So I will divide it by what? R. So NPR divided by R factorial is equal to what? NCR. Correct? For example, suppose I have got objects like A, B, C, D, E. Correct? How many ways I can arrange them by taking 3 at a time? So 5, P3, right? So suppose I have taken objects like ABC, right? And I have arranged them. So maybe I have taken ABC, then BCA, then CAB, then there are 3 factorial arrangements. But all those 3 factorials are useless because for me they are not different combinations. ABC and BCA is not different combination. It's the same combination. Therefore, these 3 factorial combinations of permutations are gone, right? So that means R factorial permutations are gone. So here there are n objects. You select R, right? You select R and whatever the selection is, that can be arranged in NPR. So therefore, NCR is equal to NPR divided by R factorial. So that gives me a formula. NPR is what? N factorial upon N minus R factorial divided by R factorial. That gives you what? A formula. N factorial upon N minus R factorial into R factorial. Now, another way of looking at it is, slightly different way. I'll prove this. Okay. Let us look at the same equation in a different way. Okay, fine. Let us see. Look at it like this. I do not know how many combinations are available if I take R objects out of n. I do not know. So I assume that the number of combination, number of selections, let us assume that number of selections of n objects taking R at a time is an unknown number, but I call it NCR. Okay, fine. So there are NCR number of combinations, right? That means I have selected NCR. So I have selected how many objects? R objects I have selected, right? How many ways of doing that? NCR. I do not know what is NCR. But I know one thing, that now I have got NCR objects. So I have selected R objects. Now these R objects can be arranged in how many ways? R factorial ways, right? So R objects can be arranged in R factorial ways, which means, therefore, these NCR selections, every selection will give me R factorial combinations, right? So R factorial permutation. So every selection of R objects gives how many permutations? R factorial permutations. Correct? So how many permutations I'll get total? I have got NCR selection. Each selection gives me R factorial permutation. So total number of permutations is obviously equal to what? NCR selections. Every selection gives me R factorial permutation, and there are NCR selections. The total number of permutations are what? R factorial into NCR. Correct? So this is nothing but NPR. Correct? So this is number of permutation, right? So therefore, I get a formula that NCR is equal to NPR divided by R factorial, which gives me this famous formula N factorial upon N minus R factorial into R factorial. Beautiful formula for calculating number of selections. So let us see whether it applies to our cases. For example, if there are 4 objects, A, B, C, D, and we have seen that there are 6 ways of selecting 2 objects. So that means it is 4C2. According to this formula, it is 4 factorial divided by 4 minus 2 factorial into 2 factorial, which means 4 factorial is actually equal to what? 24. 4 minus 2 means 2 factorial, that is 2 multiplied by 2. So 4, therefore the required answer is 6. Correct? Our answer is correct. Okay. So now, suppose I want to select 3 objects out of 4. Okay. Fine. So that is 4 factorial upon 4 minus 3 factorial into 3 factorial. That means 4 factorial upon 1 factorial into 3 factorial. But 1 factorial is 1. 4 factorial upon 3 factorial is simply what? 4. I told you that there are 4 ways of selecting 3 objects out of 4. Why? Because when you are selecting 3, you are selecting 1, rejecting 1. Okay. So, now let us see some of the important properties of NCR. Okay. So, properties of NCR. Very interesting. Now, number 1, what is NC0? Let us see. It's like, there are n objects and I don't want to select anything. What can I do? I can do it for reject all of them. That can be done in only one way. So therefore, NC0 is actually 1, and it can be done by formula also, n factorial divided by n minus 0 factorial into 0 factorial. I already told you 0 factorial is only 1. So this becomes n factorial upon n factorial. Answer is 1. Correct? Now, let us see what is NCN. That means there are n objects available and I want all of them. I don't have any choice. I have to select all of them. So that can be done only one way. But that will come once. See, look at the formula. N factorial upon n minus n factorial into what? N factorial. That gives you what? N factorial upon 0 factorial into n factorial. Even that is 1. Arey, NC0 is same as NCN. Is it a coincidence or it's a general truth? The answer is, anytime there is a relation that, because when you select R objects, I want you to understand, students, when you select R objects, you are rejecting n minus R objects. So when you select a R, obviously you are selecting n minus R, rejecting n minus R. So rejection means what? Selection for rejection. Correct? So you are selecting n minus R objects for what? Rejecting them. Right? So obviously NCR is same as NC n minus R. Very, very important identity. This is called, most important identity is called Pascal's identity. NCR is always equal to NC n minus R. Now, if you have not understood my argument, we can prove it by using formula. Right? So what is LHS here? Let us prove it. So what is LHS? LHS is NCR. What is NCR? N factorial upon n minus R factorial into R factorial. Fine. So what is NC n RHS? What is RHS? RHS is NC n minus R. What is that? That is n factorial divided by n minus R factorial into n minus R factorial. But here n will get cancelled, and what will be left? N factorial upon R factorial into n minus R factorial. Correct? So RHS and RHS are actually same. So therefore, this identity is established, right? NCR is always equal to NC n minus R. So it's very interesting to note that these numbers NC0, NC1, NC2, NC3 and so on, NCR somewhere, and the last number is NCN. The previous number will be NC n minus 1 and so on. You will realize one thing, that the first number is same as the last number. So NC0 is same as NCN. NC1 will be same as NC n minus 1. Correct? NC2 will be equal to the previous number here, because we know that NCR is same as NC n minus R. N minus R. For example, NC0 is same as NC n minus 0. So therefore it is equal to NCN. Correct? NC1 is equal to NC n minus 1, which I told you. Correct? Now NC2 is equal to NC n minus 2. First, last, second, last, third, last. They have same values, right? These numbers are called binomial coefficients. Binomial coefficients. Surprisingly, these binomial coefficients will come in our life 100 and more times, thousands of times we'll come across these numbers. They are very, very important in mathematics. They are called binomial coefficients, okay? NC0, NC1, NC2, NC3, etc., etc. So these are the properties. And I want one more property to be understood by all the students, and that property is called Pascal's identity. In the 6th century, there were two mathematicians called, one was called Pascal, and there was another mathematician. They were very famous. They used to correspond with each other. And this Pascal has done a lot of damage to the career of our students because he is a villain. You know, उसने इतना कुछ किया है मैथमेटिक्स में कि स्टूडेंट का लाइफ बर्बाद हो गया है, right? So one of the villains in your life is Mr. Pascal. So he can be rightly be called rascal, but I don't know. People call him Pascal, right? So what is Pascal's identity? Pascal's identity is very interesting. It says that NCR plus NCR minus 1 is equal to N plus 1 CR. Now, very interesting. Actually, if you look at it, it's quite obvious. Most of these identities in permutation and combination are nothing but common sense. Okay? How it is a common sense? First of all, I'll prove it by using common sense and then by using formula. The kind of proof which is given in the book is not using common sense, but they use always what? Formula. This formula proof do not give you any insight into what is happening. Okay? So what is NCR plus NCR minus 1? Suppose there are n plus 1 objects I have. I have how many objects? N plus 1 objects I have. So I have objects like A1, A2, A3 and AN. But there is one extra object. I call it, because it is different from all the rest, I am calling it alpha. So total number of objects are how many now? N plus 1 objects are there. Fine. Out of these n plus 1 objects, I want to select R. I want to select R. So what I want to find out? I want to find out what is n plus 1 CR. Fine. So there are n plus 1 objects and I have to select R. Now, because alpha is different, I will calculate it like this. Suppose I include alpha in them, then how many combinations are possible? Now, since I am including alpha, that means I don't have to select R. I have to select now only r minus 1 objects, correct? So that means, if I select alpha, that means how many objects are left to be selected from? I'm sorry, right? Alpha is already selected, therefore there are only n objects left to be selected from. So that means that can be done in NCR ways. Do you understand? I will repeat again that there are n plus 1 objects. There are n objects and alpha is different from them. Okay. So now I want to select r objects out of this n plus 1. So there are two ways of doing it. Either alpha is there or alpha is not there. If alpha is there, how many objects are there? And alpha is not there, how many selections are there? Total will give me n plus 1 CR. That's common sense. Okay. So if alpha is already selected, that means I have to select only r minus 1 objects. Out of what? N. Correct? So r minus 1 objects out of n. Here alpha is already selected. Alpha is already selected. Out of n plus 1 objects, alpha is gone. So there are only n objects are left. Out of that, I am selecting r minus 1. Now, suppose r is not to be selected at all, right? That means this alpha is not included at all. So alpha is gone from both, from the number of selection as well as the selection itself, right? So how many objects are available for selection because alpha is not there? So again n objects are available. But now I have to select all r because alpha is not there, right? That can be done in how many ways? NCR ways. So this total has to be equal to this. I'll repeat again. I am selecting r objects out of n plus 1 object. This job can be done in two ways. Either you select alpha or you don't select alpha, right? Total number will be selection of alpha and not selection of alpha, correct? That will give me total number of selections. So total number of selections are n plus 1 CR. But suppose I am already selecting alpha in them. So r में से एक चला जाएगा, n plus 1 में से भी एक चला जाएगा. So that means number of selections are n C r minus 1, correct? इसमें alpha was included. Suppose alpha को नहीं include करना है. नहीं include करना है तो n plus 1 में भी नहीं है और r में भी नहीं है, right? So how many objects are left now? N. And how many selections are to be made? R minus 1. And ये दोनों का total ये होना चाहिए. ये common sense है, right? But if I want to prove it by using the textbook method, I can prove it by using what? The normal formula method. So I'll give you the proof of that also. So I want to prove that NCR plus NC R minus 1 gives you n plus 1 CR. Correct? Fine. So I start with LHS, left hand side. Let us start with left hand side. What is NCR? NCR means what? N factorial upon n minus r factorial into r factorial. Correct? Plus n factorial upon n minus r minus 1 factorial into r minus 1 factorial. Correct? Now, that is equal to what? That is equal to n factorial upon n minus r factorial into r factorial plus n factorial divided by, now this will be n minus r plus 1, right? Because that minus minus will become plus factorial multiplied by r minus 1 factorial. Correct? Now, this means this is n factorial divided by n minus r factorial into r factorial plus n factorial divided by n plus 1 minus r factorial multiplied by r minus 1 factorial. Now, if you look at both the terms here, you can see that there are many things I can take out common. So, for example, न्यूमरेटर में दोनों जगह n फैक्टोरियल है तो मैं इसको निकाल लेता हूँ, राइट? अभी ये देखो n माइनस आर एंड n माइनस आर प्लस 1 कौन सा बड़ा है? n माइनस आर प्लस 1 बड़ा है, इससे सिर्फ एक नंबर से बड़ा है. नाउ इफ यू टेक आउट, आई टोल्ड यू n फैक्टोरियल इज ऑलवेज n माइनस 1 फैक्टोरियल इनटू n, मतलब n minus r plus 1 factorial is nothing but n minus r. So I'll write it here. Okay, so I'll write it like this. See, So this is nothing but n factorial divided by n minus r factorial into r factorial. I have not changed anything here. And here it is n factorial divided by, okay. Wait a minute. I'll just do one more thing here. This r factorial can be written as r minus 1 factorial into r. Okay. Similarly here, this n minus r plus 1 factorial can be written as n minus r factorial multiplied by n minus r plus 1. Correct? Multiplied by n r minus 1 factorial. R minus 1 factorial. Correct? So now you can clearly see what can be taken common. So here n factorial is common. Here n minus r factorial is common. Right? And r minus 1 factorial here also, r minus 1 factorial is here also. So r minus 1 factorial is common. Right? Now what is left inside? Very few things are left. 1 upon r is left. This is gone, and this is gone. So what is left? 1 upon n minus r plus 1. This is the only thing left. Okay. So that means we have n factorial, n minus r factorial into r minus 1 factorial multiplied by n minus r plus 1 plus r divided by r into n minus r plus 1. So this minus r plus r gets cancelled. Now you get a very interesting thing. See, n factorial multiplied by n plus 1. Right? Then n minus r factorial multiplied by n minus r plus 1 from here. And then r minus 1 factorial multiplied by r. So you can see there, it is like 9 factorial into 10, but that is 10 factorial. You all know. So n factorial into n plus 1 is equal to what? N plus 1 factorial divided by n minus r multiplied by n minus r plus 1. So this number is 1 greater than this. So this is the factorial now. N minus r plus 1 factorial. Right? And r minus 1 factorial into r, that gives me r factorial. Correct? So this is r factorial. Okay. So this is LHS. Now what is RHS? RHS is what? N plus 1 CR. Correct? N plus 1 CR. What does that mean? N plus 1 factorial divided by n plus 1 minus r factorial into r factorial, which is not different from what we have written here. So therefore LHS is equal to RHS. Okay? This Pascal's identity has done havoc in the world of mathematics. I will show you its multiple applications and the kind of wonderful situation this Pascal identity has made. Next lecture में I will show you the wonders of Pascal's identity. Okay? Fine. Thank you. So we'll stop here. And if you have any doubt or if you have any questions, you are requested, is my earnest request, that you pose your questions in the comment section. Okay? So, okay, and let me know. We'll try to solve the questions that you are asked. Okay? Fine. Thank you.